We are going to be taking a deep dive into the events surrounding the very period of transition between prehistory and history. That span of time lasting from the end of the last ice age up through the early Holocene, which is the current geological epoch in which we find ourselves, and it is the epoch during which we have created civilization and history. So we're going to get into that, but before I get into it, I'm going to welcome my friend and colleague, John Arthur, and producer. I always want to add that at the end, so that just so everybody who's watching is clear. If there's any technical mistakes or errors or any of that, don't blame me, okay? Don't blame me.
Anyway, always on this end. Absolutely.
So here we are, John. We're right in the middle of the summer. Actually, we're not in the middle of the summer if we figured that summer started on June 21st. Then it's over officially September 21st. Then when is the cross-quarter day? What is the day that stands halfway between summer solstice and fall equinox? That would be one of the cross-quarter days. And what is the date of the cross-quarter day? Because there's probably, I think we have, if we look traditionally, we're going to find that there have been observations and ceremonies and things that have taken place on or around the cross-quarter day. Let's say the one that would be, it would be presumably in May sometime.
So traditionally, it's February 1st, May 1st, August 1st, and November 1st.
May 1st, okay. So May Day.
May Day.
Huh. So
this year is going to be August 7th.
And then what about, what'd you just say,
sorry. This year in 2025, it'll be August 7th.
August 7th. Well, that would be, okay. Now that's getting very close to what meteor shower occurs on August 12th.
Ooh, the Perseids.
Mm-hmm. They're one of my favorites because it's usually a nice time of year to be out. It's much nicer time of year to go out and look for Perseids than it is for Taurids or Leonids. Particularly Leonids, which peak around November 17th, 18th. I've been out watching Leonid meteor showers, and it's been pretty darn cold on a couple of occasions. So Perseids,
even in Georgia?
Well, yes, even in Georgia. Yes.
Everyone's under the impression that it's always hot in Georgia.
No, we get cold weather here. Particularly as you move north, I'm on the, right where I'm at is on the lower edge of the mountains. So as you go north and you go up 1,500 feet in elevation and you go up a few degrees in latitude, yeah, you get some light snowfall every year up there. But only sporadically here where I'm at. Maybe once every 5 years you get some, which is very different from where I grew up in Minnesota, where we used to get a lot of snow every year. Yeah, I remember my job, one of my chores was to, back in those days in the country, we burned our trash. Maybe it was not the most environmentally friendly way to dispose of our trash, but a lot of it, that's what we did. So one of my chores amongst the boys was to, and it was the one I kind of volunteered for, was to take the trash out maybe once a week and burn it. And we had these big barrels, and I would, because I just loved making the fire. And so usually I'd take it out at night, light it on fire. So you start, in the fall with the first snowfall, I would shovel my path out to the burn pit out there, which was maybe 75 feet or so, 100 feet from the house. And then as the year progressed, I would constantly shovel it, throw the snow to the side. And by about March, it was a canyon of 6 feet deep. It was over my head, right? And then, of course, spring would come and all that would melt off. Within a matter of typically maybe 2 weeks at the most. And there would usually be that first day or two of spring thaw where there'd be a lot of melt. And that has always served as a very useful analogy for me, thinking about the meltwater phase of the deglaciation during the end of the Great Ice Age, because there are, of course, major differences of scale, but nonetheless, they are analogous to each other. And then these spring, so one of the things we used to do, my buddies and my brothers and I, when we were boys, was we would go out and, there would be hills, and in these hills, there would be these hollows that were formed by the rivulets of melting snow every year. And we knew that, when the snow melted, these dry, hollow places on the hillsides would turn into temporary rushing creeks. So we would build dams. We'd build dams out of logs and rocks and mud and so forth. And then once the meltwater started coming, it would create sometimes 2 and 3 feet deep behind the dam. But then, of course, what would happen is the dam would get overtopped, and then eventually half the dam would wash away. But it was cool to see the surge of water coming down. And I know that doing that sort of inculcated this really fascination with flowing water, and now extrapolating from that up to thinking about ice dams and gigantic flows and reservoirs that essentially are obeying the same laws of physics, but just on a different scale. Anyways, so back to the Holocene. We're back. We now know, and I think most of the listeners will know, that the date now given for the inception of the Holocene, the current epoch, that's the word we use, an epoch, is a subgrouping of the period. The geological period is divided into epochs. So we are in the Quaternary period, and the Quaternary consists of the Pleistocene epoch and the Holocene epoch. Now, it's interesting to think about the comparison between the two, because the Holocene, the Holocene, 11,600 years ago. In some of the older literature, it was typically rounded off 10,000 years, 12,000 years. But recently, with the transition, the climatic transition that took place at 11,600 is serving as that line of demarcation now, and is a given. If you look up, let's just check it. Look up Holocene dates, and let's see what it says. And this is a relatively new, I'd say, in the last decade or two, couple of decades, to give that precise of a date for the inception of the Holocene. What is it saying?
So 11,700 is the current estimate.
Okay, 11,000. Yeah, so 11,700. Okay, so other sources will give it as 11,600. But now it's dated again. So the point, it's dated to within a century. Okay, so it would be worth looking at what specifically now has defined that in the minds of geologists, that they're able to go, oh, Holocene's 10,000 years old, or the Holocene's 12,000 years old, to now saying that the Holocene is 11,700 years old, right? Well, one of the things that's very interesting about that is that it is now a very, very well-defined boundary line between the Younger Dryas substage and the pre-boreal stage, which is now where the climate of the Earth has shifted very rapidly from glacial cold of the Younger Dryas into the warmth of the early Holocene. So that change in climate occurred very abruptly. And we have looked at the Greenland ice core graphs, where you can see how the climate spikes at 12,900, then it drops into full glacial cold, and then it spikes back again at 11,600, 11,700. And then from there it climbs up, and then it stays pretty much steady state, fluctuating 1, 2, 3 degrees sometimes throughout the Holocene until we get down to modern times. But clearly, those climatic fluctuations that brought the Ice Age to an end were extreme. They were severe. They were planetary. And they were associated with the rapid disappearance of the great megafauna. They were also associated with the disappearance, that period of time, with the North American Clovis culture. Now, we've looking, there is evidence emerging from studies all over the planet of a major disruption of human population. Generally, up to this point, it was considered to be the result of migration. Okay, so we've got this evidence, let's say, of this culture in Japan from 12,000 years ago, right? And they're there, and then this particular group here, the settlement, was abandoned. Well, that means that the people who were living there got up and moved somewhere else. But what it appears to be happening is when you look at somewhere else, you're seeing, well, wait a minute. So here's point A. They abandoned that and they went to point B. So we hypothesize, where's point B? We look at point B and we discover, oh, well, point B was abandoned as well. So it really is beginning to look like there's a major disruption of human population at the least severe level. At the most severe level, it could even possibly be a bottleneck in the human population, perhaps that's missed genetically because there are so many separate and disparate groups of survivors of that cataclysmic end to the Ice Age, that there was enough diverse genetic material that it obscured the fact that the human population numbers dropped precipitously. I think we could be looking at numbers like 90% of the human population did not survive the Younger Dryas, just like the other megafauna. When I do my research, whether it's ancient history, cataclysms, or unexplained anomalies, I rely on the best tools available. Just like I wouldn't head into the Channel Scablands without the right gear, or without clothes for that matter, I no longer venture onto the internet without one essential tool: ExpressVPN. Most people don't realize how exposed they are online. When you browse the internet, your activity can leave tracks, just like footprints in the sand in Bruno Canyon. That data can be harvested, sold, and used by advertisers, big tech companies, or even malicious actors. ExpressVPN shields your internet traffic, encrypts your data, and keeps your browsing private. This keeps your ISP from tracking your browsing habits. It also keeps your connection secure from hackers when you're on unprotected Wi-Fi networks, like at the airport or your favorite coffee shop. ExpressVPN has partnered with us to support this show, and they're offering my viewers 4 months free when you sign up at expressvpn.com/Randall. So if you'd like to support the work we do here and protect your data at the same time, then it's expressvpn.com/Randall, where you'll have 4 months free. So thank you, and now let's get back to the show. See, here's the thing. You can't just assume that there's going to be these extreme events that can wipe out millions of animals, megafaunal animals, millions. Frank Hibben, back when he was researching and wrote his book, it'll come to me in a second, Frank C. Hibben. He wrote a book in the 1940s where he was one of the early catastrophists because he went up and saw for himself. He was following bulldozers and the gold prospectors, looking at the prospecting for gold by using these high-pressure hoses, and they were blasting away the permafrost. And he went up there and studied that, what was being revealed when they were blasting away this permafrost. And what he saw, he thought unambiguously showed that there was a catastrophic end to the Great Ice Age. And he wrote about it extensively in that book. I think it was 47,
Would
The
that be
Lost
The
Americans.
Lost Americans, the story of man?
Yeah. What was the year of publication on that? So I would
1946.
Frank Hibben estimated 40 million megafauna. That's what I was trying to get at in a roundabout way. 40 million megafauna. Now, I think that number roughly holds up. It gives us at least a framework for thinking about it. Now, the critics of the impact hypothesis, which we're going to look at here in a second, we'll take one as an example and start unpacking it. They'll say, well, okay, if it was an impact, it should be instantaneous. Okay. It shouldn't have taken 1,000 or 2,000 years, which it appears that it did. It appears that there were extinctions going on, but again, we're still sorting it out. You know, we don't. I mean, working these chronologies are tough because some of the dating methods, you know, only have a plus or minus of 150, 200 years. So right there, you could be as much as 200 years off in one direction. But see, here's what I think we'll learn is that this idea that you had to have an instantaneous extinction of 40 million animals, and if you didn't have that, that disproves any kind of an impact scenario, just to me, just doesn't hold up. Because first of all, you have to concoct an oversimplified impact model, for one thing. And there's no reason to assume that the only potential scenario is going to be a single large impactor slamming into the earth. And you can see that in the early critiques, this is the model that they're debunking. So this is the paper, Evidence for an Extraterrestrial Impact 12,900 Years Ago that Contributed to the Megafaunal Extinctions and the Younger Dryas Cooling. Now, there's a lot to unpack in this paper that came out, and I think we determined here that there were, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there was 20-some, couple of dozen scientists working on this paper. And it's a dense paper, and it covers a lot of material. I only have the cover, the first sheet, the first page of the paper here. But and it is very much worth, and of course, if you want to get this paper, it's easily accessible. I mean, I think Google Earth has probably got it accessible, not hidden behind a paywall. I know that George Howard over at the Cosmic Tusk, you could download a copy of it there. I couldn't recommend enough downloading this and actually taking a little time and reading it. And I know that
Google Earth or Google Scholar?
I probably said Google Earth when I meant to say Google Scholar. Yeah, I don't know if you're going to be able to download the paper from Google Earth. Again, I'm deeply sorry. I profoundly apologize for that misstatement. So anyways, here they dated it 12.9 thousand years ago. Ka, remember everybody, K is 1,000 and A stands for years. So this is 12,900 Ka. If you see the BP after it, that means before present, right? So a carbon-rich black layer, previously identified at 50 Clovis Age sites across North America. Here's the things that are also, as it says, appear contemporaneous. The abrupt onset of the Younger Dryas cooling, the in situ bones of extinct Pleistocene megafauna, Clovis tool assemblages, which occur below this black mat layer and not within or above it. Now, they're not the ones who have proclaimed that. That is coming from C. Vance Haynes and other distinguished archaeologists who, in their papers, have commented that very point, that it appears that the Clovis assemblages and the megafauna are below the black mat, but not above it. Now, I think, and I haven't kept up with the most recent, I would not be a bit surprised that you would find some megafaunal remains above the black mat. Why? Because it's perfectly feasible and reasonable to assume that there would be species, that numbers of species that eventually became extinct that did survive, individuals of species that did survive. Well, we know the woolly mammoths did. On the Randall Islands, they survived. And we see that they diminished in size between the late glacial maximum and the early Holocene, when they were still alive on these islands. They had been reduced to about half their mass from what they had been during their peak size and weight. So they adapted. That doesn't necessarily, in my mind, prove evolution. It proves that species adapt, but not necessarily. It's one thing to say a species adapts. It's something else again to say that it turns into another species. But that's not a discussion for this episode. Anyways, we know that some individuals did survive. And obviously humans survived, because here we are, John. You and I are living proof that we humans did survive. Unless you and everybody else is an illusion, I'm assuming now that there is some basis in reality, and that, yes, humans survived. Even though their numbers may have been reduced, we did survive, and we have repopulated the earth, just like the analogy I always like to invoke to try to help get some perspective on this is the near extinction of the American bison around the turn of the century. When I think I read that it was the total numbers were reduced to something like 60 individuals. Maybe it was 60 mating pairs, 60 individuals, not very many. But of course, the species has completely rebound. Now, important point here is that if we were paleontologists 10,000 years from now looking back, you'd be lucky to actually even identify the near mass extinction event of the American bison. It would get lost, because we're talking about an event that was essentially a century or a century and a half between, numbers where there are millions of them down to where there were just dozens of them. And then now we're back, I presume, millions again. How easy would it be 10,000 years from now to miss that? I mean, if you're, by whatever means, if you're looking at coprolites, or maybe some kind of something that would be literally associated with bison, because obviously if bison are out grazing, they're part of the ecosystem, they're leaving traces. Well, if you look from the 1700s, they're there. If you look from the 21st century, they're there. How are you going to know, unless you make a much more precise sampling, that, oh, geez, look what happened. There was a population bottleneck right here. The species came this close to extinction, but they recovered. So I think it's fair to say that it's likely that species that are now extant also suffered losses during these Younger Dryas events, just not enough to cause the complete extirpation of the species. And likewise with we humans. But so causes for the extinctions: Younger Dryas cooling and termination of the Clovis culture have long been controversial. In this paper, we provide evidence for an extraterrestrial impact event at 12.9 Ka, which we hypothesize caused abrupt environmental changes that contributed to Younger Dryas cooling. 1, major ecological reorganization. 2, broad-scale extinctions. 3, and rapid human behavioral shifts at the end of the Clovis period. So here we have a whole bunch of stuff that happened within a very narrow range of time. So do we say each of these things that happen, and this does not mention the mega floods either. We have rapid melting of the great ice sheets associated with the rapid warming, generating gigantic meltwater floods in the northern hemisphere. We have the loss of the species. We have the loss of, or disruption, major disruption of human population, etc. Climate changes of up to 10 degrees centigrade in literally a few years. So all of these things are happening within this narrow window. Now, here's two approaches to it. Are those events even though they're associated in time so closely, so tightly, they're all just separate, completely unrelated events that just happen, and essentially any connection or correlation is coincidental. Or does it make more sense? Is it more rational to look for a common cause and say maybe the rapid climate changes, maybe the rapid melting, maybe the extinction of the megafauna, the disruption of human society are all the consequence of a single cause? Or now, in my mind, yes, that's kind of an outrageous hypothesis, because then you're faced with the question, well, what would that single cause be, right? Yet to me, as extraordinary as that scenario would be, it's more believable than to think that all of these things are just unrelated and happen to be coincidental in time. That it's purely coincidental that you have mega floods measured in hundreds of millions of cubic feet per second, and the majority of megafaunal remains are found in fluvial deposits. In other words, water deposits. And yes, we could go through the literature, and we'll do that, and you'll see that over and over and over again, we're finding the remains in, if we're not speaking not in northern latitudes where you have permafrost, but there you find them in permafrost, frozen in permafrost. And in some cases, in many cases, the megafaunal remains are not just bones anymore. They're also got tissue and muscles and fine structure, fine anatomical structure still being preserved in the cold. There's evidence now suggesting that somewhere, and this is not precise yet, between 30 and 40,000 years ago, there was a major catastrophic event. Maybe not planetary, but certainly drastically affected northern latitudes. And the bone beds that are showing up appear to have recent dates. I say recent, end of the Pleistocene, younger Dryas dates, and then also a cluster of dates from much earlier, maybe around 35, 36,000 years ago. And I think even, the bone bed in Alaska, I think they have that. I think we've seen that clustered dates. So I would think then that it's at least less unreasonable to assume and to look for, and I think entirely legitimate to look for a single overriding cause for those events. And what does that leave us? Well, so now here we have this team coming along here. Okay, Clovis age sites in North America are overlain by a thin, discrete layer, varying peak abundances of magnetic grains with iridium, magnetic microspherules, charcoal, soot, carbon spherules, glass-like carbon containing nanodiamonds, and fullerenes with ET helium. Fullerene, do you know what a fullerene is?
Fullerenes are molecules composed entirely of carbon arranged in a close or partially closed mesh of fused rings.
You got a graphic?
The third major allotrope of carbon. Let me pull.
Look at what a fullerene looks like.
Let me get a
let's
good
share
graphic.
that with the listeners. Yes, it's fullerenes are very interesting objects, things, molecules.
There we go. There's a C70, a C60, an 80, and a 180.
Yeah, look at the C60. So what you got there is a soccer ball.
Mm-hmm.
Each face, you can see there's pentagonal and hexagonal faces. An allotrope of carbon, yes. So these has intrinsic mechanical, biomedical, electrical, magnetic, and optical aspects. Fullerenes named after who? Buckminster Fuller. author of Synergetics. He was the inventor of the geodesic dome. That's why it's sometimes called a Fuller dome. And the reason that the fullerenes are called this is because he experimented and built structures such as you see right here. And if you look at his books, 2-volume set Synergetics, amazing books. I've never been able to get through them all the way from cover to cover. If I live another 150 years, though, I will. I'm making a commitment that I will. But yeah, I still find lots of interesting stuff in there dealing with his whole geometry and his way of explaining epistemology and ontology in the terms of geometry, not geology, geometry. Anyways, why are we talking about this? Well, because glass-like carbon containing nanodiamonds and fullerenes with extraterrestrial helium, all of which are evidence for an ET impact and associated biomass burning at 12.9 Ka. This layer also extends throughout at least 15 Carolina bays, which are unique elliptical depressions oriented to the northwest across the Atlantic coastal plain. We propose that one or more large, low-density ET objects exploded over northern North America, partially destabilizing the Laurentide ice sheet and triggering Younger Dryas cooling. Notice now, he's not saying that the Carolina bays are impact-produced. He is saying, though, that they found that layer, that what he's calling the impact layer, throughout at least 15 Carolina bays. So let's take a look at what the skeptic says. Now, the date here, October 9th. Now, 2008 comes out. And notice we've got January, the Geological Society of America today. So this, but before we go on, I just want you to notice January. Now, we talked about this, John, like, okay, so if the Firestone paper came out October 8th, so now we've got November, December, January. So 3 months, less, and presumably in most cases, the journal comes out before a week, even several weeks before the month, right? So here's the first thing. Now, there was a lot of claims put forward by Firestone and team, right? They found nanodiamonds, they found iridium, they found this impact layer with magnetic grains, microspherules, etc. Okay, so if you're going to refute this, you need to go out and replicate the work. You need to go out and look, because this is what they've been doing. They've been out in the field now taking samples and testing them. These 24 scientists in some of the most sophisticated laboratories in the world. Okay, but so here now is the response to that. And you got to ask, okay, if you got to figure this thing was not carefully the result of careful consideration, examination, etc. I mean, how would that even be possible? I think we could say that how quickly, at what point was this paper right here submitted to Geological Society of America today? Obviously, it had to have been there probably even in December. Well, it had to have been there in December, maybe even November. So I think we can clearly understand that this is not going to be some careful attempt to replicate the work or the claims put forward by Firestone. It's not going to be a fair-minded consideration of the possibilities here. Like, did they find nanodiamonds? Did they find microspherules? Did they make this up about the Carolina bays? Now, they didn't put forward necessarily any claims about the Carolina bays. They just said that in 15 Carolina bays that they examined, they found this layer. Okay, now the Carolina bays is a very controversial, the origin of them is very controversial. We know that, right? And some people have claimed since the 1930s that they were impact produced. Others have said, no, they were not impact produced. However, the work of Firestone, now you have to go back and say, okay, let's try to replicate their work. Let's go look, find that layer that they sampled in the Carolina Bays, independently corroborate whether the impact proxies are there. Okay, but until you do that, you're not really in a position to say, oh no, there's no significance to the Carolina Bays, has no relevance at all. So we're going to go through this now because this is the rebuttal. This is the rebuttal, the first rebuttal now that came out in the aftermath of the publication of this paper. So in November 2006, the New York Times reported the identification of a growing number of impacts and associated mega tsunamis during the past 10,000 years by the, and then they've got it in quotes, the Holocene Working Group, right? This is the scare quotes. Like when you're actually trying to say, that, oh, the Holocene Working Group, ha, 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 you know, that's what this is. In contrast, using astronomical and planetary data, Bland and Artemieva in 2006 calculated that impacts capable of producing hazardous tsunami occur only once every 100,000 years. Well, so obviously it's nothing that we need to concern ourselves with. If it's something that's only going to happen every 100,000 years. How they determined that in 2006 is questionable. And we could come back and look at it because in 2006, who has been examining the coastlines of the world looking for evidence of tsunamis that have been right under our noses? See, this is almost 20 years ago now, right? In the last 20 years, we've learned and been able to perceive a whole lot more about the coastlines of planet Earth than 20 years ago, right? Identification of Holocene mega tsunamis was based largely on, again, chevrons, a new term for coastal landforms attributed to mega tsunami runup. Madagascar chevrons were linked to an Indian Ocean crater identified, and again, they have noticed they've got quotes. Now, in the original paper, it was double quotes, not single, but because I'm using double quotes to define the extract from the article, I'm using single quotes here. So Madagascar chevrons were linked to an Indian Ocean crater identified by ocean floor topography and splashes of iron, nickel, and chrome fused to foraminiferal tests in nearby ocean cores. Since foraminifera play such an important role in dating, let's go ahead and look up foraminifera so people can understand what they are. They're mostly planktonic. I think there are benthonic species as well. They live in the ocean, in the water column. Foraminifera.
Foraminifera, single-celled organism.
Mm-hmm. Collected from San Francisco Bay. Oh, the early, look, notice the little, the spiral shell.
Yes.
There's a lot of different varieties of foraminifera.
There you go.
Yeah, look at that. Yep. Photomicrographs of living planktonic foraminifera. So that means that they live in the water column. They're not bottom dwellers. They live within the water column. But when they die, all those shells sink to the bottom of the ocean and form extremely thick layers after a while and eventually get compressed and metamorphosed into limestone or calcareous rocks of whatever nature, but limestones typically. And wait, go back one. There's, let's see. Yeah, here's the, let's see if we can pronounce this. I practiced. I learned how to pronounce this once upon a time. Globerginoides.
Orbulina universa.
Glober. Got to get that G in there. Globerginoides.
Globigurnoids.
Well,
Globigerinoids. Jeez.
the bigger,
Sackleper.
the globigerinoides. I think it's globigerinoides,
Rinoides. Okay.
something like that.
Someone's going to correct us in the comment section. So
That would be fine.
that.
Look, if you know
Please do.
the exact correct pronunciation of this word, let us know.
please do.
Please do, because my life will be
More complete.
inestimably more complete. Yes, if I know how to pronounce that word, and then I can. I'll have something to do in my spare time. I can practice saying that word. Okay, what else does it say about them? Dating is a good thing. Let's see. Oh, here, this is good stuff too. Diagram, the life cycle. Okay. This is not what the spiraling direction depends on the temperature of the ocean water. Let's see.
So here's some fossils.
Okay.
Ooh.
Yeah. Now that's getting interesting, isn't it?
So
Huh.
it's been interpreted as a fossil, but
That looks. They're hexagons, aren't they?
mm-hmm.
Interesting. Put in foraminifera. Oh, yeah, dating, or climate. Foraminifera climate, or maybe there's something here if you scroll down. Yeah, there we go. Dying planktonic foraminifera continuously rain down on the seafloor in vast numbers. Their mineralized tests preserved as fossils in the accumulating sediment. Have been yeah, okay. Beginning in the 1960s. Yeah, the effectively unlimited supply of these fossil tests and the relatively high precision age control models available for cores has produced an exceptionally high quality planktonic foraminifera fossil record dating back to the mid-Jurassic. Yeah, okay, so, but yes, because certain types of foraminifera are found only in certain environments, their fossils can be used to figure out the kind of environment under which ancient marine sediments were deposited. Conditions such as salinity, depth, oxygenic conditions, and light conditions can be determined from the different habitat preferences of various species of forams. So foraminifera, yeah, are generally called forams for short. Yes, so this allows workers to track changing climates and environmental conditions over time by aggregating information about the foraminifera present. So back to this. So we were down to this point right here. No studies of the KT impact have reported foraminifera with fused metals. Well, okay, so what they're saying here, because the mega tsunami was the work of Dallas Abbott and several of her colleagues, whom we're going to be having a conversation with within probably the next week or two. And we're going to get her on to talk about her more recent research that definitely involves mega tsunamis, because she's gone way beyond where the discussion was in 2008. But they're making this point here. So Madagascar chevrons were linked to an Indian Ocean crater identified by ocean floor topography and splashes of iron, nickel, and chrome fused to foraminiferal tests in nearby ocean cores. So did Dallas Abbott find iron, nickel, and chrome fused to foraminiferal shells? That's what we're talking about when we're talking about tests, right? Okay, so to me, that would be pretty interesting evidence if it's true. So either, if this is being dismissed, it can only be, A, that it was untrue, which means either that Dallas Abbott and her team were lying or they were mistaken. Because if you do have nickel, iron, and chrome fused to these foram shells, you're talking about, well, so then they go on, they admit the melting points of iron, nickel, and chrome are greater than 1400 degrees centigrade. Okay, so they're acknowledging that. Well, to me, then, if you dredge from the ocean and you come up with a spike, an enhancement, an enrichment of forams, and they've got nickel, chrome, and iron fused to them, and that requires temperatures greater than 1400 degrees centigrade, well, that's pretty significant in my mind. But then he says this is by way of dismissing. No studies of the Cretaceous Tertiary impact from 65 million years ago have reported foraminifera with fused metals. Oh, okay, so you go to another boundary and you say, okay, well, they haven't been reported there. Well, therefore, we can just dismiss it. I mean, that's what they're doing. They acknowledge that it's 1400 degrees centigrade plus, greater than that, that's the melting point. Well, okay, so again, okay, well, if that argument that they're making, well, no studies of the KT impact have reported foraminifera with fused metals. Well, I'm not sure that that's true, but let's assume that's true. But the fact that it's not been reported from another horizon, okay, well, there's probably lots and lots and lots and lots of horizons where it hasn't been found and reported. Does the statement that so far, up to this point, 2008, is it because maybe nobody specifically looked for that? I don't know. I don't know why. Maybe there was no fusing of these metals to foraminiferal shells at KT, or maybe there was. We don't know. But in any case, what they're saying is none has been reported. Well, therefore, it follows that the report of finding from the Indian Ocean is of no relevance. Or you see what I'm saying here?
Correct. It doesn't follow.
No. And then here's the comment. Identifying impact sites by searching for dimples on Earth's surface is a dubious proposition. For example, Speranza et al. In 2004 documented a sheep watering hole identified as the Sorrente crater. So Speranza in 2004, yes, I think if you go to Google Earth, put in, not Google Earth, Google Scholar, sorry, put in Speranza et al. 2004. Okay, so in this paper from 2004, they're saying that this proposed impact crater is actually a sheep watering hole and was dug by humans. Okay, so Pinter and Ishman, the authors of this paper, cite this as this is an example of searching for dimples on Earth's surface. Okay, so impact sites, identifying impact sites by searching for dimples on Earth's surface is a dubious proposition. For example, Speranza 2004 documented a sheep watering hole identified as the Sorrente crater. Okay. The Holocene impact mega tsunami story, we collected meteorological data from two Chevron sites, Montauk, New York, and Faux Cap, Madagascar. In both these cases, these features were precisely aligned with the dominant wind direction and had been mapped previously as parabolic dunes. We suggest that these Holocene features are clearly Aeolian, deposited by wind, and that the term chevron should be purged from the impact-related literature. So, these aren't the mega tsunami deposits that Dallas Abbott and her team are identifying, are not deposited by tsunamis. They're just wind deposited. And the term chevrons, never mind that these features do look like chevrons, never mind, we should just purge that term from impact-related literature. Now, pull up. Now, let's go to Google Earth. Zoom right in down there. Okay, now follow the coastline around. Okay, stop right there. Zoom in. I think we've looked at this before, but let's look at it again. Hey, chevrons. What should we call them if we don't call them chevrons? You guys got a better name? They sure look like chevrons to me. But
and
now,
how are these Aeolian? I mean, where are they coming from if they're Aeolian? I mean, you're looking at the lithology, right? Like, has anyone studied this?
Yeah, I mean, okay, so what you have here is entirely consistent with water deposition, because as you go towards the distal end of this, up you'd say to the northwest there, you'll see that basically you've got a wave that's washing ashore, reaching its limit right up there. You can see where the sand stops. I mean, it's really obvious. And what's happening there is the water is moving up gradient. It's losing momentum. It's losing its energy, and it's depositing the finer grained stuff. And then it flows back out. And it's the flowing back out that creates these chevrons. Because if it's a single directional flow, you basically get parallel to subparallel ripple marks, bed forms, right? But then when you have a bidirectional flow, like within a tsunami, which makes landfall, washes up, then comes back, right? It transforms these subparallel, because they're parallel, subparallel, right? Okay, now zoom in and come up to the northeast, pan, stop. Okay, now you see there's that dark line on, go, move your cursor up. Let me see, I can't barely see your cursor. Where's your cursor?
You're looking right up here?
Oh, no, back down to the edge. I'm trying to get you to see the escarpment. There's an escarpment running all along. You were right on it.
And right over here.
Yeah, zoom in, and you can follow that escarpment down to the southeast. Might have to zoom out a little bit to get the picture.
Yep.
Okay, so now what I want you to do, let's see, let me move this. I'm going to go ahead and...
It's really pronounced right here.
There we go. Okay, so the reason it's pronounced there, okay, now zoom out so we can get the picture. Okay, good. Okay, so here's what, now, okay, the whole story is right here. Zoom in back to where you said that the escarpment is very pronounced. Yes. Okay, now follow that escarpment up to the northwest and keep going and stop. Let's see. Okay, what's happening there is that this is where the washover occurred. In other words, if you go down and you go see where that escarpment is very easily identifiable and pronounced, there's no washover there. If you zoom out, you can see very clearly, zoom out a little, right there, you can see where the overwash occurred. Follow the escarpment, right there. Yeah, right there is where the overwash occurred.
Yep.
Okay, so what's happening there then is once the escarpment is still there, though, it's buried under hundreds of feet of the overwash. So it's not as obvious, see, as you're going here, what you're seeing is that down where the escarpment is obvious, the wave did not overtop the escarpment. And then you go a little further to the northwest, and right there, the wave overtopped the escarpment. Now, here's the thing. That escarpment is about over 600 feet above sea level. So it means that the wave, when it made landfall and overtopped that escarpment there, had to be over 600 feet deep. That's a pretty impressive, but see, this was all just created by wind. I mean, if we start looking at that, does it make any sense that this is a wind deposit?
No.
It doesn't seem to like wind.
So, yeah, you're going to have to tell me why the escarpment has so much extra density that it's not affected the way all of the sand, deposit from the ocean floor right here.
Mm-hmm. Well, what it looks like, if you zoom out here, it looks like you've got a secondary deposit of sand. You've got this sand that was deposited up at the distal end. I'm guessing this second closer to shore sand here was the result of a secondary wave that came in without the strength of the initial wave that made landfall. But look, just leaving it right there, you can look at that and you can see the escarpment coming up from the lower right, and then you can see where the overwash occurred. You can see very clearly the outline of it. Now, if this is wind, is the outline of that depositional, that deposit of material up there going to be so clearly articulated? I wouldn't think so. And so this is going to be interesting, but we'll get into this conversation with Dallas when she comes on, and we'll talk about this. But then if you scroll out, a very impressive, now go up, follow the coastline to the northwest, and you'll get to the, I think you might have gone too far. Let's see, zoom
right
in.
here.
Yeah, there you go.
Yeah.
So if you hover, you can hover over, like hover right up at the edge. You can see where the chevrons, you can actually see the borderline of the chevrons very clearly. You come up to the point up there. So that would have been as far inland as the wave reached before it reversed and flowed back out. Hover right over the section near, like the top edge of the topography, and look at the. You should be able to read the elevation on the lower right. Down there below, on the very bottom right, you'll see latitude, longitude, and elevation.
63 meters.
63 meters. Okay, so let's just quickly convert that. So that's 206 feet. So that is ultimately, the wave had to be that high, although it probably had its run in probably has forward momentum. But at the same time, the wave is diminishing in height. So probably it means that this wave making landfall had to have been at least a couple of 100 feet high. And something else that you could do, but zoom out again. We're going to mark that distal point of the wave, and then you should have a measuring tool. Yeah, there we go. Okay, so measure from that point parallel the axis of the whole thing to where it looks like it would make landfall.
So 21 kilometers.
Okay, so 21 kilometers is going to be, let's see. So
13.2 miles.
Yeah. So let's see. Do you think I think you might actually need to go a little further along the coastline.
Okay. Let's do it. You come all the way right over to here.
Yeah, because that's probably where the wave made landfall, didn't it?
Yeah, that's 24 miles.
24 miles. So it had the momentum to travel 24 miles over land. Now, if there was any coastal settlement or community at all along that particular reach of the coastline, of course, it's going to be utterly, completely, 100% obliterated.
Correct.
Without any But yeah,
No
you can.
trace.
No trace. No trace. We suggest that these Holocene features were clearly Aeolian or wind. So to these guys, they're clearly wind. And therefore the term chevron should be purged from the impact-related literature. Here's the key. These features were precisely aligned with the dominant wind direction. Were they? Okay, the qualifier here is the word dominant. So then there was also subordinate wind directions. And how accurately have you charted the dominant wind directions through the millennia? I mean, come on. So we go and so the dominant wind direction. Okay, so how dominant? How dominant are they? I mean, is it 6 months of the year the wind is blowing in this direction? Because we know that the direction of the wind changes constantly throughout the course of the year, almost no matter where you are on the planet. So I would say this is a very tenuous way of debunking. Oh, it's wind. No more discussion. We don't need to discuss it anymore. Clearly, it's wind, and we should just throw out the term chevron from all impact-related literature. Now let's go back, because remember, they said that this Speranza, they documented a sheep watering hole. So, these impact nuts, they're going out there and looking at a sheep watering hole and thinking it's a impact site. I mean, you can almost read the attitude here, can't you? Well, okay, 2008. Okay, so let's go down here. I got something on that. This is from 2006. So this was the original paper, okay, that followed. This was the paper that followed. See, we just looked up, and you pulled up the paper where he was arguing that it was a sheep watering hole. Okay,
the anthropogenic origin of the Serenite crater.
Right, that's it. Okay, so now, and what year was that it came out?
Came out in 2004.
Okay, so this came out 2006, 2 years later. So the proposed Serenite crater field consists of a slightly oblong main structure or main crater 120 meters in width and about 30 smaller structures or satellite craters, all in unconsolidated but stiff carbonate mud. Here we focus on the subsurface structure of the satellite craters and compare the Serenite field with known crater fields. We present a more complete outline of the crater field than previously reported and information on the subsurface morphology of a satellite crater, 8 meters in width, also with radiocarbon and thermoluminescent ages of materials from this crater and evidence for heated material in both crater C8 and the rim of the main crater. So basically, this is the upshot of this research. Now that comes 2 years after the study that said it was a sheep watering hole that was dug by people. Together with the previous radiocarbon age, before present, of 1,538 years ago. So let's see, this was 2006 minus 1,538 would have made this around 468 AD, roughly. The formation of the main crater, which is the target surface below rim, and a formation is suggested at the beginning of the first millennium AD. Although projectile vaporization is not expected in Serenite-sized craters in this type of target material, we used geochemistry in an attempt to detect a meteorite component. The results gave no unequivocal evidence of meteoritic material. Nevertheless, the outline of the crater field, evidence of heated material within the craters, and the subsurface structure are comparable with known meteorite crater fields. So we could dive into this because particularly the evidence of heated material within the crater is very interesting. But for the sake of time, and I know you've got to get onto your next project soon, this was 2008. So here you have, and these are, let's see, these are people, Department of Geological Sciences, Christian Corbero, recognized expert on impact cratering. Angelo Pio Rossi, International Research School of Planetary Sciences. Goro Komatsu, Research and Scientific Support Department. Where is he? The Netherlands. Yeah, so he's done work on megafloods. We'll encounter his name again. Anyway, so these four, we presume, who are highly qualified, highly credentialed scientists, say this, that while the results gave no unequivocal evidence of meteoritic material, nevertheless, the outline of the crater field, evidence of heated material within the craters, and subsurface structure, because you've got layers that are overturned. You're not going to have heated material necessarily. We'll have to look deeper into see what is the nature of that heated material and how hot, what did it have to, what temperatures was it heated to. But certainly with heated material and overturned strata, that's consistent with impact. And that's what they're saying here. They're not saying that they've proven its impact. But then the evidence is comparable with known meteoritic craters. Yet, again, look at what the team here of the critics is doing. But now, this isn't all. We got 2008. Let's come to 2022, much more recent. And here we have, this appeared in the Acta Geodetica et Geophysica journal. The subsurface structure of the proposed Sorrente meteor crater, insights from ERT synthetic modeling. So this is where it gets to me really interesting. The Sorrente meteor crater is approximately 130 meters wide, in plan view, droplet-shaped depression with an elevated rim, which is consistent with crater. I guess you could say, well, if humans dug it, they piled the earth up in an elevated rim. Would they do that? I don't know. Maybe if they were trying to get deeper ponding of water, I don't know. But it is consistent with an impact event, okay? Given the age of the formation in the 3rd to 5th centuries AD, the inferred catastrophic origin was related to the celestial sign Chi Rho, said to have been seen by Emperor Constantine in 312 AD, and suggested to have changed the course of both Roman and Christian history. However, the meteoritic origin is not yet confirmed. This paper presents new results from synthetic modeling of electric resistivity tomography, field data collected at the Sorrente main crater, which provide further clues around the controversy of its origin. This study arises from the need to validate the observed structural features, which include possible upturned strata or overturning of strata below impact crater rims, and compaction fissure-like features below and just outside the crater rim, which would be consistent with a shock force, right, rather than just some guys there digging, and well-developed breccia lens, broken rock, as well as an ejecta layer, and provide key indicators for objective and quantitative interpretation of the measured resistivity pattern. The results from this study are consistent with the hypothesis of a small impact crater in a low-strength target with a relatively shallow apparent crater, and do not support the other proposed mechanisms of formation, such as karst, mud volcano, or merely anthropogenic origin. Now, I think we should just go back for a second and look at what they're saying here. For example, Speranza et al. In 2004 documented a sheep watering hole identified as the Sorrente crater. Sorrente crater, ha ha ha! Oh, these misguided impact enthusiasts, catastrophists. Hey, we're going through this because I want people to see the level of the counter attack to the impact hypothesis. Because there's people out there saying, the impact hypothesis, that's been disproved. Then they wave their hands, because by waving your hand, that can make it all go away. And just as close scrutiny of the Holocene impacts belies an extraterrestrial source. So that's just what they did. They made a close scrutiny of Holocene impacts, right? That was their reference to the Sorrento crater. So they just did a close scrutiny of Holocene impacts, belies an extraterrestrial source, an impact on the southeastern Laurentide ice sheet at 12.9 Ka, proposed at the 2007 American Geophysical Union Joint Assembly, engenders similar doubts. The purported impact is cited as a trigger for the Younger Dryas climate event. Well, they admit there was a Younger Dryas climate event, extinction of Pleistocene megafauna, demise of the Clovis culture, the dawn of agriculture, and other events. Evidence of the 12.9 Ka impact includes magnetic grains, microspherules, iridium, glass-like carbon, carbonaceous deposits draped over mammoth bones, fullerenes enriched in helium-3, and microscale nanodiamonds. So 7 proxies, okay? We suggest that the data are not consistent with the 4 to 5 kilometer diameter impactor that has been proposed, but rather with the constant and certainly non-catastrophic rain of sand-sized micrometeorites into Earth's atmosphere.
So wait, you're telling me that these proxies for impactors, which are considered proxies because they're not commonly found on the Earth's surface, are the result of a micro meteorite shower?
Well, because every day a few tons of
Cosmic dust
accretes, falls, filters slowly, non-catastrophically, gently through the atmosphere.
Then why are these considered proxies?
Well, they're saying, we suggest that the data are not consistent. Well, first of all, we have to go back and examine closer the 4 to 5 kilometer diameter impactor that has been proposed. That was one proposition amongst several of trying to get some kind of comprehension of what are these proxies that we're finding? What do they mean?
Yeah, as opposed to a set of smaller comet-like impactors that would have been in a stream.
Right. Well, they don't see here in this critique here, they don't mention a multi-impact event. They're immediately going to the one which, yes, you can pretty much demonstrate that it almost certainly was not a single 4 to 5 kilometer diameter impactor. Okay. And we'll come back to that. Why can we do that? And why it's almost certainly more consistent with a smaller series of multi-impacts. But then notice here, after they have this evidence, right? So this evidence now, this 2007 report is the first evidence in the scientific press that these guys went out, these 24 scientists went out and they looked and they found what they believed to be a spike of hypervelocity impact proxies at the Younger Dryas horizon, which is very close, if not directly on, the dating window when all of this other stuff is alleged to have occurred. So now what they're doing is they're saying, well, we found this stuff. Okay, so either they found it, but it's just the gentle rain of the stuff that comes down, the microscopic dust that falls on the Earth every day, certainly non-catastrophic, as they say here. I should underline that. Certainly non-catastrophic. So either they're making this all up, or they're all mistaken. None of this evidence really exists. And if it does exist, it should be easy to demonstrate that it's not a spike within the stratigraphic column. It should be consistent, right? Throughout the stratigraphic column. If it's just a gentle rain of microscopic dust coming down, right? Why would there be a spike? Universally found in now dozens of sites, right? But now notice how they flip the script. The 12.9 Ka impact story has struggled to bring its disparate evidence under a single umbrella. So the impact story originated in Firestone and Topping 2001 and the Firestone et al. 2006 book, both of which contain observations and claims so wild that other work by these authors invites careful scrutiny. Okay, so in the spirit of William R. Davis, the founder of geomorphologies, The Value of Outrageous Hypotheses, a very important paper that should be read by people who are involved in this kind of research, because he's really excoriating his colleagues for being so constricted and hidebound in their thinking that they're missing a lot of stuff and have missed a lot of stuff. And he cites multiple evidences, even back in the 1920s, of things that an overly constricted framework of thinking has missed that have turned out to be scientifically valid. Hence the paper, The Value of Outrageous Hypotheses. Now, in the spirit of outrageous hypotheses, yeah, Firestone and Topping are speculating. And they're like, okay, we don't know what this is, but there's all of this stuff. So in the interest of speculating, we're not going to confine our thinking to only the tried and true, only the most pedestrian of explanations, right? They did that, sure. But then they go on, here, these two guys go on to say that the nature of the 12.9 event changes radically with each iteration, from a supernova-generated cosmic ray jet to a massive atmospheric airburst to multiple ET airbursts along with surface impacts. Well, so in other words, they're thinking. You're bringing this team of people on. They're testing ideas. They're still in that phase of, okay, here's the evidence. Let's try to explain it. See, this is the natural progress of scientific inquiry that we're looking at here. And what are these guys doing? Well, they're saying, well, because different hypotheses have been proposed by different researchers, well, what that means is that it has struggled to bring its disparate evidence under a single umbrella. Well, you're looking, so the paper's proposed, published in 2000 in late 2007. Here you are a few months later, and they're saying how it's struggled. Well, obviously, this is something that warrants considerably more research and investigation. And of course, this has happened. And that's where we're going to be looking at in the next few episodes of where this research has gone and what do we now know in 2025 about this. But then they finally make this comment. Airbursts are a convenient explanation. Given the lack of an impact crater, we'll come back to that one, tektites, shocked quartz, or high-pressure minerals. Okay, now it's interesting that the things that, so there's multi-proxies, right? Nanodiamonds are a proxy. Magnetic grains are a proxy. Microspherules are a proxy. Iridium is a proxy. I mean, for Christ's sakes, it was iridium that first alerted scientists to an asteroid impact 65 million years ago, right? Okay, so those are accepted proxies. But so are impact craters, tektites, shock quartz, or high-pressure minerals. Now, every one of those, a crater, requires impact into the ground surface. Excavates a crater. Tektites also impact into the ground surface. The splash, which is now a combination of the impactor and the target material, molten together, rain back out on the Earth. So, boom, impact into the shocked quartz. Also, bedrock, high in quartz, high in feldspar, you're going to get these shock quartz, the parallel lamellae that is indicative of high pressure. Again, impact directly into the target rock, into the ground, right? But so what they're doing here, see, is they're taking, okay, those impact proxies, a crater, shocked quartz, tektites, high pressure minerals, right? Again, indicative of an actual impact into the ground. And they're saying, well, it's none of those, so we can just dismiss the other proxies and either imply that those 25 scientists don't know what they're talking about, they're mistaken, or they're all got together, it's a big conspiracy, and they're telling a fib, which is not the case. So, where does that leave us? Well, I think at this point, people can see what's being played out here. So airbursts. Oh, well, airbursts are a convenient explanation. Well, yeah, but it's an explanation that fits the data, that fits the evidence. It's not a convenient explanation, given that there's no crater yet identified. Remember, it was 10 years between the iridium layer of the KT Chicxulub impact crater and the actual identification of the crater. It was 10 years. We'll end with this quote. The 12.9 Ka impact story has also struggled with the broad range of impact-related materials reported. Firestone and Topping identified chondrules, suggesting that the impactor was a chondrite. Magnetic grains and spherules are consistent with an iron-rich meteoroid, whereas silicate materials suggest a stony meteoroid, and glass-like carbon and carbon spherules suggest a carbonaceous source. All of that is true. Firestone et al. Suggest geochemical affinities with lunar crustal material. I've got this next line underlined. Any one of these might be a credible extraterrestrial source, but together they are a Frankenstein monster, incompatible with any single impactor or any known impact event. Incompatible with any single impactor. So, are we talking here about a single impactor? I would say no. Any known impact event, I would say there's probably lots more impact events that we don't know about than we do know about. And we're just learning. I mean, every impact crater and ongoing studies, we're learning more and more. And we're just at the very beginning of learning about impacts into oceans. And we know, think about it, I mean, over 70% of the Earth's surface is ocean. So there's got to be impacts into oceans. But if these guys have their way, chevrons are just you're going to throw that out. We're not even going to talk about that, right? I would agree, though. Yeah, we're dealing with a Frankenstein monster here. But that doesn't mean that the monster is a fantasy, make-believe. I think we are dealing with a Frankenstein monster, and this Frankenstein monster is very real. And we need to come to grips with what this Frankenstein monster is. So in their concluding statement, and we're going to pick this up at the end, in the next episode, both the 12.9 impact and the Holocene mega tsunami appear to be spectacular explanations on long fishing expedition for shreds of support. Both stories have played out primarily in the popular press. So well, if the popular press happens to pick up on it, well, that negates the hard work and rigorous work that was published in the scientific press. So better not have the popular press pick up on it at all, because then guys like this will use that to discredit. Both stories have played out primarily in the popular press, highlighting how successful impact events can be in attracting attention. Well, you think? The desire, but here's what it is. The desire for such attention is understandable. in an environment where science and scientific funding are increasingly competitive. So here it is. It's this team of the 25 scientists that wrote this paper. It's the desire for attention. And of course, to these sages, these elites, these members of the establishment, the scientific establishment, the scientific community, they can render judgment on these, that it's really just the desire for attention. The National Science Foundation now emphasizes transformative research, and few events are as transformative as an impact. I got this underlined for a reason. In an era when evolution, geological deep time, and global warming are under assault, this type of science by press release and spectacular stories to explain unspectacular evidence consume the finite commodity of scientific credibility. Ooh, well, we're in an era where evolution might be questioned. Ooh, or not even questioned, assaulted. That global warming is under assault. So, you see what I think we can begin to see the motive here maybe behind it. Yeah, they're admitting. Well, yeah,
This
in an
affects our
environment.
worldview, our basic understanding of humanity's history.
Well, it
So-
does that, yes, but it says that the desire for such attention is understandable in an environment where science and scientific funding are increasingly competitive. So if you give money, get this, if you give money to impact research that perhaps potentially profoundly affected human life on Earth, profoundly affected the biosphere, profoundly affected history, you might be taking away money that would otherwise go to global warming. That's the takeaway here, John. I think that's the takeaway. And
your worldview has a lot to do with how you affect it affects your science. It affects your observations. What you
absolutely.
believe about the world changes how you work as a scientist.
And the last thing is in the wake of that paper, we have now phys.org.com. Comet impact theory disproved. Oh, well, yeah. A month of pulling together a few threads here and there. Now they've disproven the impact hypothesis. How do we know today? New data published today disproves the recent theory that a large comet exploded over North America 12,900 years ago, causing a shock wave that traveled across North America at hundreds of kilometers per hour, and triggering continent-wide wildfires. We didn't address that yet, but we certainly will. Dr. Sandy Harrison from the University of Bristol and colleagues tested the theory by examining charcoal and pollen records to assess how fire regimes in North America changed between 15 and 10,000 years ago, a time of large and rapid climate changes. Their results provide no evidence for continental scale fires, but do support the fact that the increase in large-scale wildfires in all regions of the world during the past decade is related to an increase in global warming.
Mm-hmm.
See, this is, you can see how this,
look at the man behind the curtain. All the research might point one direction, and it's not in the way that I'd like it to, but don't look at the evidence.
Well, that's kind of what it's looking like, isn't it? So we're going to pick up where we left off, and we're going to come forward and see. We're going to work through. We won't hit everything, but there are a number of key pieces of research that have come out that are really interesting and important and valuable for confirming the idea that there was some type of cosmic impact event, and that the protestations of the critics have pretty much evaporated in the onslaught of new convincing evidence that something happened. What that was is still up for grabs, although in my opinion, it probably almost certainly involved impact phenomena, but it may have also involved the sun. I think we could make a strong argument for that. And we're going to be laying out a scenario over the coming episodes of Squaring the Circle that attempts at a sort of a unification of cosmic catastrophism that involves impacts, that involve galactic ray bombardment, that involves solar storms, all as a unified system that ultimately has repercussions for what happens down here below on the surface of the Earth, all the way from climate change to earthquakes to volcanoes, mega floods, ice ages, etc., etc. So we'll see how far we can get with this work, but I hope everybody stays with us and follows this. And for you young people out there that are interested in something, a fascinating career, think about getting into the sciences, the earth sciences. Think about getting into astronomy. Think about looking at prehistory with eyes unfettered by and unconstricted by obsolete dogmas, because I think we're on the threshold of a major scientific reorientation of the whole human story on Earth. So, John, I think you're going to need to get on the road. So, as always, it's been fun. It's been a pleasure, and I look forward to the next one.
Likewise, sir.